4 laboratory sections took the same assessment. We know every section size, 3 section means, and the exact mean for all 100 students. Our job is to recover the missing mean for section D.
This is a student-produced response, so there are no answer choices to test. We need an exact number, and the phrase computed from every student's score tells us how the overall mean was formed.
Let me read the source table carefully. Section A has 18 students with mean 72, B has 24 with mean 78, C has 30 with mean 84, and D has 28 with an unknown mean.
Before calculating, check the counts. 18 plus 24 plus 30 plus 28 equals 100, exactly matching the total in the prompt. That confirms that the 4 rows include every student.
I am tempted to average the section means, but section D is missing, and the prompt specifically warns that the overall value did not come from averaging 4 section means.
Exactly. A section mean represents every student in that section. A mean for 30 students must contribute 30 scores, while a mean for 18 students contributes only 18 scores.
So instead of combining means directly, I should convert each group into its total score. Then all 4 totals can be added because they measure the same thing.
Start with the overall mean. The fraction 2052 over 25 may look awkward, but multiplying it by all 100 students gives the total score across the laboratory sections.
Because 100 divided by 25 is 4, I can simplify before multiplying. 4 times 2052 is 8208.
That 8208 is not another mean. It is the sum of all 100 individual assessment scores. Keeping that interpretation clear prevents us from dividing at the wrong time.
Now section A has 18 students averaging 72. Its total score is 18 times 72, which is 1,296.
For section B, multiply 24 students by the mean of 78. 24 times 78 equals 1,872.
Section C has the largest listed group, 30 students with mean 84. Its total is 30 times 84, or 2,520.
The table makes those unequal weights visible. Even a modest difference between means can affect the combined mean strongly when it belongs to a larger section.
Adding the 3 known totals gives 5,688. That is the contribution from sections A, B, and C together.
All 4 sections total 8,208. Subtract the 5,688 already supplied by A, B, and C. The remainder must be section D's total.
The difference is 2,520. Interesting. Section D's total matches section C's total, even though the 2 sections have different numbers of students.
That observation helps us distinguish total from mean. Section C spreads 2,520 points across 30 students, but Section D spreads the same total across only 28 students.
To turn section D's total back into its mean, divide by its 28 students. 2,520 divided by 28 is 90.
The requested student-produced response is 90. Notice that 90 is above the overall mean, which makes sense because section D must lift the combined result after the lower means in A and B.
Can we represent the whole calculation as one weighted mean equation? That would show exactly where every count belongs and give us a second route to the same answer.
Let D be section D's mean. Add each count times its mean, then divide the total by 100. Set that weighted expression equal to the given overall mean.
Multiplying both sides by 100 removes the outside denominator. The three known products combine to 5,688, so the equation becomes 5,688 plus 28d equals 8,208.
Subtract 5,688 from both sides, giving 28d equals 2,520. Divide by 28, and d equals 90 again.
The table and equation now tell the same story. Counts are the weights, means are the per-student values, and each product reconstructs the score total for one section.
Let's verify in the original context. Put 90 back into section D. 28 students times 90 gives 2,520, precisely the missing section total.
Then the four section totals are 1,296, 1,872, 2,520, and 2,520. Their sum is 8,208.
Divide that grand total by all 100 students. 8,208 over 100 reduces to 2,052 over 25, exactly the overall mean stated in the source.
Now let me test the equal mean shortcut explicitly. If I average 72, 78, 84, and 90 as four equally weighted numbers, I get 81.
But the actual overall mean is 2,052 over 25, or 82.08. The shortcut misses because the larger sections C and D have the higher means, and therefore deserve more weight.
So averaging subgroup means works only when all subgroup sizes are equal, or when I intentionally apply the correct weights. Here 18, 24, 30, and 28 are not equal.
Here is a useful mini-practice. 3 workshop groups have 10 students averaging 70, 20 students averaging 80, and 10 students with an unknown mean. The overall mean for 40 students is 77.5.
I will pause at the total step. 40 times 77.5 gives 3,100 total points. The two known groups contribute 700 plus 1,600, which is 2,300.
Subtracting leaves 800 points for the final 10 students. 800 divided by 10 gives a missing mean of 80. The same total first method works immediately.
My reusable plan is: add the group counts, turn the overall mean into an overall total, turn each known group mean into a group total, subtract, and divide by the missing group's count.
And keep the units attached mentally. A mean is points per student. Multiplying by students gives points. Subtracting point totals is valid. Dividing the missing point total by students returns points per student.
For the source problem, 100 students contribute 8,208 points. Sections A through C contribute 5,688, leaving 2,520 for D.
Section D has 28 students, so its mean is 2,520 divided by 28. The exact source answer is 90.
The key idea is not to average averages blindly. Reconstruct the totals that produce those averages, combine or subtract those totals, and only then divide by the appropriate number of observations.
The weighted table, the one equation method, and the full substitution check all agree. Section D's mean score is 90, and every one of the 100 student scores is represented exactly once.
Optional SAT math study resources are linked in the description. If you purchase through an affiliate link, the channel may earn a small commission at no extra cost to you. As an Amazon associate, I earn from qualifying purchases.